Study the effect of pushover analysis for G+15 story R.C.C structure with and without zipper frame using SAP 2000. Abstract: the modern earthquakes, including the last Algerian earthquake in which many concrete structures have been severely damaged or failed, have shown the need for assessing the seismic capacity of existing buildings. In particular, the improvement of older concrete structures in high seismicity areas is a focus of increasing concern, since structures vulnerable to damage must be identified and an adequate level of safety must be determined. To make such an assessment, simplified linear elastic methods are not sufficient. Thus, the structural engineering community has developed a new generation of design and seismic procedures that include performance-based structures and are moving away from simplified linear elastic methods and towards a more nonlinear technique. Modern concerns in the development of performance-based codes for the design or improvement of buildings in seismic alert areas show that an inelastic procedure, commonly referred to as the pushover analysis, is a viable approach to assess damage vulnerability of buildings. Pushover analysis is a range of incremental static analysis carried out to produce a capacity curve for the structure. Based on the capacity curve, a target displacement, which is an evaluation of the displacement that the design earthquake will produce on the building, is determined. The extent of damage encountered by the structure at the target displacement is estimated representative of the damage experienced by the building when subjected to design-level ground shaking. Many methods were presented to apply the nonlinear static pushover, NSP, to buildings. Certain systems can be listed as A. The capacity spectrum method, CSM, B. The displacement coefficient method, DCM, FEMA 356, C. ATC 40, and D. Modal pushover analysis, MPA. In this paper, study the effect of pushover analysis for G+15 story R.C.C structure with and without zipper frame by using SAP 2000 software. Also, for the increasing performance of R.C.C framed structure, types of bracing systems are used in framed structure for seismic design, such as zipper braced frame. Improving seismic behavior of structure by the new bracing system is called zipper braced frame. Keywords: pushover analysis, zipper bracing, SAP 2000, hinges, formations, etc. 1. Introduction: nonlinear static analysis. Pushover. The nonlinear static analysis uses the simple inelastic approach, which differs from a traditional static linear procedure that reduces seismic forces to levels that allow designing buildings under the assumption that they remain. Though chimerical and doubtless offensive, this oversimplified approach works well for brand spanking new buildings and typical existing buildings. Secant method. When the analysis of building is complete with the secant technique, a worldwide elastic model of the structure made. The stiffness values calculated for the modeled parts and parts. In general, the response spectrometry can predict a unique displacement pattern than assumed. The pushover curves area unit, accustomed to choose a brand new set of parts, secant stiffness supported the displacements foretold by the world analysis. Method of pushover analysis. A. Load control. It is used once the load is thought, such as gravity load, and also the structure is predicted to be able to support the total magnitude of the load that is applied in this procedure steps. B. Displacement control. In this methodology, the magnitude of the load combination is exaggerated or diminished as necessary until the management displacement reached a predefined price. It is used once specified drifts RE unit wanted, the magnitude of the applied load ISN acknowledged before. The structure is often expected to lose strength or become unstable, or once displacement occurring within the design earthquake is understored. The pushover analysis of a structure may be a static nonlinear analysis underneath permanent vertical masses and step-by-step increasing lateral masses. The equivalent static lateral masses or so represent earthquake-evoked forces. A plot of the entire base shear versus high displacement in an exceedingly structure is obtained by this analysis that may indicate any premature failure or weakness. Nonlinear static pushover analysis. The existing building will become seismically deficient since seismic design code needs our unit perpetually upgraded and improvement in engineering data. Further, Indian buildings engineered over the past 20 years are system seismically deficient owing to lack of awareness concerning seismic behavior of structures. Zipper bracing frame. One of the practical ways to prevent these frames undergoing large lateral displacements is to use diagonal members, called brace. A frame in which bracing is used called braced frames. This system is similar to chevron system, but only just one additional element, which was a vertical structural member, connected at the top and down to the beams at this vertical strut named as the zipper, and a frame in which zipper braces were added called zipper brace frame. These members increase the lateral stiffness of the frame and enhance the capacity of the energy dissipation by plastic deformations. Adding steel braces enhance greatly the strength capacity of the buildings. On the dynamic characteristic of the building, the zipper bracing systems are found the most efficient. 2 preliminary data considered for the analysis. Building details. 1. Architectural details. To study the behavior of R.C.C. building under high seismic forces as here taken. Area covering, 24.5 x 19.5 m. Total height of the building, 45 m. Floor to floor height, 3 m. Column details. 3D model is being prepared for the frame nonlinear. Static analysis of the building in SAP 2000 software.